Hi everybody, welcome to Operations with Squares and Cubes. In order to be able to do this lesson, you have to have at least practiced your notation of squares in order to be able to do operations with squares. And in order to be able to do operations with cubes, you have to have practiced notation of cubes. So if you have not done either one of those, you're going to need to stop this video, go back, do those lessons, and then come back and join us once you've practiced them. So we're going to start with operations of squares, and then we'll be able to jump from cubes pretty easily from there. So I have made this PDF and emailed it to your parents. You don't have to use this. I wanted to be able to offer you a copy of each of the squares so that if you did need to count at all, you have that option available to you. However, it is much easier if you have these numbers memorized. So you can color these and cut and paste them onto your paper if you want. You can just use them as a reference. I'm also going to show you how you can do this work just on a piece of graph paper. Okay, so let's go ahead and get started. I am going to set this to the side. I've already cut out a few of my squares, and we're going to start small. We're going to go ahead and add 2 squared plus 3 squared. And I'm going to write that on my paper. So 2 squared plus 3 squared equals. So the first thing we have to ask ourselves is, well, what in the world is 2 squared? Now you remember from notation of squares that 2 squared means 2 times 2. So what is 2 times 2? Well, that's 4. And we know that 3 squared means 3 times 3. So what is 3 times 3? Oh, that's 9. And then we would add those numbers together. What's 4 plus 9? Good. It's 13. So 2 squared plus 3 squared equals 13. And you can check yourself here by counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay? So if you would like, you of course can glue these down. I don't have glue upstairs with me, so I'm just going to place them down for now. But let's go ahead and do another one. I'm going to, of course, put a little design. Simple. I don't want you guys to have to sit here and... So let's go ahead and do 5 squared plus 6 squared. Okay. So here I have my 5 square and I have my 6 square. So we know that 5 squared means 5 times 5. What is 5 times 5? Well, that's going to be 25. 6 squared is what? 6 times 6, which is 36. Now we have to add these numbers together. I find it is much easier to add them vertically rather than horizontally. This is horizontally going from side to side. I am going to stack my numbers up like this. 36 plus 25. And that way our units line up with our units, our tens line up with our tens. It's a lot easier to add. So we do 6 plus 5, that's 11. Put the 1 there, put the other one, carry it. 1 plus 3 is 4, plus 2 is 6. So 5 squared plus 6 squared equals 61, like that. Okay, so, and you can, again, you can count these to verify. I'm not going to sit here and count 61 beads with you because that might be boring, but this is your basic overall idea of what you're supposed to do with this work. Let me show you a couple example problems. See, just like that. So you would find out how much each one of these equals. 7 squared is 49. 3 squared is 9. And then you would have to add 49 plus 9. 58. Okay, so that's how you would find that, the answer to these problems. So let me show you how you can do this on graph paper. Here's my piece of graph paper. And I'm going to do 4 squared, which is yellow. Don't worry, I'm going to do small squares so you guys don't sit here and watch me color in a whole bunch of dots. You can just color in the whole entire squares of the graph paper, but I'm just doing circles because it's a little bit faster. So I have 4 squared plus, I'm going to go ahead and do 3 squared because that one will be nice and small for me to draw. 1, 2, 3, 1, 2, 3, and 1, 2, 3. Like that. So let's go ahead. This is 3 squared. So 4 squared is what? 16. 4 times 4 is 16. 3 squared is 9. So we need to add these. 16 plus 9. What is 6 plus 9? 15. 25. Like that. 25, that's interesting. Isn't 25 the square of 5? Very interesting. I wonder if you're able to do that with any other numbers. So pretty much what we're doing is we're taking our squares and we are adding them together. We can also subtract them. So we could do 6 squared minus 3 squared. So I'm going to write that here on my graph paper. 6 squared minus 3 squared equals. So what is 6 squared? Again, 6 squared is 36. What is 3 squared? Well, that's 9. So we need to do a subtraction problem. Again, this is a horizontal way of writing it. We can also write it vertically. 36 minus 9. So we're going to have to borrow, aren't we? We're going to have to exchange this, a 2. We change the 3 to a 2. And then the 6 to a 16. What is 16 minus 9? 7. Sorry, ignore my mistake there. And then 2 minus 0 is 2. So that equals 27. Okay. Let's do another one of those. We can do 5 squared minus 3 squared. I'm going to put a little box around that problem. So 5 squared minus 3 squared. So 5 squared is 25. And 3 squared is 9. I'm actually just going to go ahead and start out by writing it that way. So we're going to have to exchange, aren't we? Because we can't take 9 from 5. This 2 becomes a 1. This 5 becomes a 15. 15 minus 9 is 6. 1 minus 0 is 16. So it equals 16. Now, if you are working on large bead frame with red zeros, or flat bead frame with multiple digits, or if you are just practicing doing long multiplication on paper, it is possible for you to multiply some of these. So we would do 5 squared times 3 squared. 5 squared is 25. 3 squared is 9. And you would go ahead and however you are practicing your multiplication, whether it be with material or on paper, you would go ahead and find this answer. I'm going to go ahead and tell you the answer. It's 225. Now, if you wanted to get really big, you could do 9 squared times 8 squared. Ooh. What is 9 squared? 81. What is 8 squared? 72. Fascinating. Anybody who's practicing long multiplication, 2-digit multipliers, I want you to tell me what this answer is. I'm not going to tell you. But go ahead and give it a shot, okay? So we are going to just do those 3 operations. We're going to wait on any kind of division. And let's go ahead and move on to cubes, operations with cubes. Okay, so I have a couple of the cubes from Notation of Cubes that I made. However, it can be pretty difficult to count these cubes. I don't know if you remember that I had talked about working on memorizing your cubes, which is very important. What you can do, if you like, I'm just gonna make a little stack because maybe if it'll stay, because it's fun. What you can do is if you had made your own tickets for that follow-up work, you can take out those tickets, put them in order, and that's gonna help you remember your cubes if you haven't already memorized them. So let's go ahead and write down a problem. Let's do 4 cubed, sorry, that's a really big 3. 4 cubed plus 5 cubed. So here's where you need to know your cubes. What is 4 cubed? It's 64. Okay, now what is 5 cubed? 125. So we need to go ahead and add these. I'm going to go ahead and stack them vertically. All right, now we just do a simple addition problem. 5 plus 4 is 9. 2 plus 6 is 8. 1 plus nothing is 1. So 4 cubed plus 5 cubed equals 189. Okay, let's put a little design around that problem. I would normally do a little bit more on my design, but again, I don't want to spend video time just decorating a design. So let's do another one. What if we did 7 cubed plus 6 cubed? All right, well, you got to start by asking yourself, what is 7 cubed? 343. Okay, what is 6 cubed? 216. I'm just going to start by stacking them vertically, and then you do an addition problem. 3 plus 6 is 9. 4 plus 1 is 5. 3 plus 2 is 5. So 3 cubed, oh sorry, I made that into a square, my bad. 3 cubed plus 6 cubed equals 559. Let's pick a pretty marker. I know some of you are really, really, really good at decorating your math problems. Let's do, cubes down. We'll just put these little beauties. We'll put them right here. We can decorate our little film space. Let's do 8 cubed plus 3 cubed. Okay, what is 8 cubed? 512. Okay, what's 3 cubed? 27. And then we're going to add them. 2 plus 7 is 9. 1 plus 2 is 3. 5 plus nothing is 5. So 539. So do you see why it's important, or it makes your life a heck of a lot easier, if you have your cubes memorized? Okay, so there's addition. Let's go ahead and do some subtraction. Let's start this way. 9 squared minus 5. I keep saying squared. 9 cubed minus 5 cubed. All right. 9 cubed is 729. 5 cubed is 125. How am I going to write this problem? Which one of these numbers is going to go on top? 729 or 125? 729 goes on top. Why? Yes, It's the bigger number. Whenever you do subtraction, you're writing the bigger number on top. If you are having trouble with that, you need to go back and practice your subtraction, your dynamic and your static subtraction, okay? All right, I had to say it just in case. Okay, let's do this. So 9 minus 5 is 4. 2 minus 2 is 0. And 7 minus 1 is 6. 604. Awesome. Let's do green this time. Ooh. I'm going to do one more subtraction. Then we're going to do a multiplication. Yeah, get ready for that. Because that's exciting. Talk about big problems. Let us do, how about 6 cubed minus 4 cubed equals. So 6 cubed is what? 216. 4 cubed is 64. Equals line. Now we're going to subtract. 6 minus 4 is 2. 1 minus 6. Can't do that, so we got to exchange. This 2 becomes a 1. This 1 becomes an 11. 11 minus 6, 5. 1 minus nothing is 1. 152. Okay? So that is the gist of subtraction of cubes. Let's take a look at multiplication. This is where it gets real fun. Let's do 6 cubed times 7 cubed. Okay. Yeah, I'm excited. What is 6 cubed? 216. What is 7 cubed? 343. And we have to multiply it. Now, friends, you need to be doing plus, 3-digit multiplication, either with the red zeros on the large bead frame, the flat bead frame, or if you're just doing it on paper, okay? I'm not going to give you the answer to this either because I want somebody to tell me what the answer is. So, again, we're going to leave division for another day. So I'm going to put another decoration. Even though this problem is incomplete, it shall be complete when somebody tells me the answer. So that is operations with squares and cubes. Okay, so if you have any questions, please reach out. Again, if this is confusing to you, you need to go back to notation of squares and notation of cubes, and that will really help. Okay, just reach out if you need anything. I think you're all just fantastic. Okay, bye.